Hello everyone. We decided to change. I decided to change to do it early today. I've been doing it late for the past 2 or 3 days. Kind of took a toll on me, so I decided to do it early and see if we can have a better luck. So it's April 27th today. Let's get to it. I got fresh mind. I just had my breakfast-ish thing. Doesn't matter. All right, let's take a look. Power of 3. Given an n, return true if it's a power of 3, otherwise false. Okay. Could you solve it without loops or recursion? Huh. I mean, power of 3. There are tons of methods, I guess. You can do this. You can do loops for sure. And I think I use one of the techniques, right? So we can divide it by like by 3, and then by hold on, how much should we divide? Like by 3, and then we divide by 3 squared, and divide by. I mean, this is one we want to multiply, want to create, multiply by 3 to the 31st. So I mean, we can just keep divided by 3, keep divided by 3, and then that's it. Divided by 3. Then we just see divided by 3, divided by 3. Could it be like an easier way of doing this? I'm trying to think. Well, 3, 3. I mean, 2 to the 31st minus 1. So we can list all. I don't think there's that many. We can just do a log, right? 2 to the 31st. 2 to the 31st minus 1 is this. If we log this, divided log 3. Only 19 values, because 3 to the 19th is already, yeah, so it's only 19 values. So what we can do, well, it's tremendously simpler than yesterday. I mean, yesterday was not hard, it was just, I was not prepared. I don't want to think about yesterday. Yesterday was actually pretty bad. That question is not hard. I mean, yeah, this one, obviously, this is like a cheating method, but I mean, there's no way, no rules say we cannot cheat, right? I mean, there are many ways we can cheat. We can do the log, right? We do the log, and the log will be a float. You need to determine whether the floating value is an integer. Oh yeah, I know. So there are many ways. So let's do the math way first. This is a cheating way, right? So we're gonna say math.log. Let's log what's x? Logarithm of x to the given base. So n given 3, right? And then we're gonna int, and then we say 3. We're gonna power this equals n. So to return this, that shall work. I run our own test cases. What do we have? We have 27 is true. 0 is 0 is gonna cause trouble because we can now say log 0. So let me say false. Oh, we can just say n. Yeah, I'll just say false if n is 0, else. How about negative? We can do negative. Wait, no, we cannot do negative. Negative value will always be false, right? Yeah, because 3 to the power cannot be negative. It'll always be false if it's a negative, because it cannot do. So it's actually smaller equal to 0. All right, so it's not small equal to small equal to 0. And then that's false. What's next? 9, that's true. And then 45, that's false. All right, and then I'm gonna pass n, and this one will be is power 3n. Solution 3. Okay, so that's 1, right? That's 1. We can do solution 2. Oh, you got a wrong answer. What? What the heck? I got a wrong answer. How? 243. Wait, hold on. 243 log 243 divided by log 3. Hold on. Yeah, and 3 to the 5th. This is some Python issue. Gotta be some Python issue. Alright, let's just bring it up. Import the math.log 243 and 3. Oh, shoot! That is correct. Alright, this one does not work because of this. Because of this. Alright, we're just trying to be... no, yeah, because of the whatchamacallit, the rounding. I cannot do it. Alright. I don't want to write a loop, because the loop... Alright, let's just write a loop. While true, if n 3, right, then return false. Otherwise, n divided equal to 3. And now we'll keep going until while n, right? While n, and no, while n is larger than 1, right? Because divided by 3, and eventually will be 1, and 1 will exit, which means we're going to say return true, right? This name 0 is a special case, right? So if n equal to 0, and return no, smaller equal to 0, and return false, right? Actually, I can do it here, return true. If n larger than 0, else false. So save a few lines. Okay, this one shall work. Yeah, it has, but this one is using loop, so this one shall work. This one is using loop. Not gonna do recursion, and because like this one 19, right? Only 19. So what we can do is set it here. Power of 3's equals what? Set 3 to the p for p in range. Well, n is an integer, yeah. P in range 19, 20. So we can go all the way to 20. All right? And now we just return n in self dot power of 3s. So that counts as a solution that does not use, well, I mean, it does use loop. I have a loop at the beginning. Oh no, I didn't. Oh no, that's fine, that's fine. Yeah, that's fine. I was thinking about the negative values, so don't worry about negative values. So this is since there are only 19 power of 3s available in the designated range of n, we can list them all. All right. Let's see if we can do some analysis, right? Some analysis to reach it. So what we're saying is 3 times 3, right? So for power of 2, right? Power of 2 is just 1 0, right? This is 1 followed by many zeros. Now power of 3, do we have something similar? So 3 is 1 1, right? How about 9? 9 is 1 0 0 1. Actually, it's not 1 0. I think it's 1. It's 1 0. No, 1 0. 1 0 1 5. 1 0 0 1. Yeah, 1 0 0 1. How about 3? So 27. 27. What's 27? 27 is and it is just constantly divided by 3. 27 is, if it's binary, I don't see how this one can work. What's 27? I don't know. 27. I don't think it follows any rule. 27. Let's check 27. I don't want to calculate myself. Ah, you are in environment. So just bin 27. 1 1 0 1 1. All right. So actually, let's just do this. For I in range 20, right? Print binary 3 I. All right, let's take. I actually don't like this way. 0 1. We're gonna go 1, so we don't have to look at 2. Jeez, come on, man. All right, 1 1 1 1 0 0 1. I do not see any pattern. No, there's no pattern. Maybe Python has a tool. Python, what's a tool? Other, what do you call it? Other, it's not binary. 3 based. I don't know. I don't know what I'm trying to say. It's like 2 binary trinary? Is that something like trinary? No. Binary with different base. What's that called? I don't know. It's just binary numbers. Now, what I want is not binary numbers. It's oh, this one. Any base. That's it. In the base. The reverse. Uh-huh. Uh, no. Into base. You have to do all this. Yeah, you have to do it yourself. But it only does those three bases. Okay, now I cannot do it. No. NumPy. Oh, NumPy. I can do NumPy. There's NumPy here. Yeah. I'm not sure. Let's just import NumPy as np. Alright, so we can say np dot what? Base represent. So dot base. Oh, I forgot. Base what? Base rp represent n 3, right? Base equals 3. Print. Given 27. Yeah, let's do 27. So what do we have? Yeah, yeah. So what? So we need to count number of ones. First one is 1. Is that a string? Yeah, I think that's a string. So first is 1, and remaining is all zeros. How do we... Yeah, we can count. Just count. So first one is 1, and then there are only... So I'm going to have... 3 base plus this, right? And return. I want to check minus later. And then return 3 base. Okay. I want to see what does minus is. Probably just put a minus sign there. What if it's minus? Yep. What if it's 0? And put a 0. So what we shall return is 3 base larger equal to 0, larger than 0, and let's just call it tb 3 base, right? And tb.count 1 equals 1, and tb 0 is 1. That will be false. Hold on. Oh, shoot. So let me just do n larger than 0. Yep, that shall work. Ah, the hell? Oh, nope. Yep, this one shall work. It's a NumPy solution. 45. Why? Why is 45 not right? What do we have? Oh! I have to count the number of zeros, not ones. Okay, so number of zeros has to equal to yeah. Is there like an easier way to do this? There gotta be an easier way to determine that this is, we start with 1 and the remaining is 0. How do we do this? Well, you end. So we can do a binary in that. But then we need a mask. Right? And we need a mask. That'd be hard to come up with a mask. So count 0 equals len tb minus 1. That shall work. Right? But still just counting number of zeros. Right? Counting number of zeros and then check. The first one is a 1. The easier one goes first. Goes first. Okay, this one should be right. Yeah, so the NumPy solution. Do I have NumPy? I'm not sure actually. I might have NumPy, I might not have NumPy. Turn into base 3. And check whether the base 3 value consists of all zeros except 1 and the first position. Actually, I'm not sure. I think actually I might have it. Uh-oh, I don't have NumPy. I don't have NumPy. That's fine. Let's install it. Right. So pip install NumPy. Yep. Tout it and build it. All right. Pip install upgrade. There we go. Okay. So now let's show. Oh, hold on. This is not connecting to the. We have to run it here. This one is connecting to the global. It's not connecting to the local. The global doesn't have NumPy in it, which is fine. I can run it locally. Python 3. Actually, this one will be easier to turn. That takes so long to run. Yeah. Well, what would happen if we say, I know NumPy has, actually, let's just try here. Import NumPy as dialog. Param. I should know which one's which. Oh well, 27. No, 243. 3. What the hell? I forgot. What do we have? Log. I mean, like we are already Let's upload this. NumPy log. Let's compute the natural log. Okay. This is like log 10, right? Base 10. How about this must be base 2? Yeah. How about this one? One plus. What is this one used for? So it has to be 243 divided numpy.log 3. Yeah, it's the same thing, so I cannot use it. Totally fine. Totally fine. We just comment out this solution. All right. What else can we surmise? Well, I mean, the last digit will be 3, 7, and 1. 3, 7, 1. So the last digit has to be 3, 7, 1. So that eliminates a lot of the possibilities. And then what? I don't know. I don't know if there are any other ways to do this. I have 3 solutions. This is an easy one. There's no question about it. But I'll vote regardless. LeetCode 326. All right. Okay, what type of solution? Loop base conversion. If it is written as leading one followed by all zeros. Wait, let's do the render. Convert number to base. Turn the results. Oh wow! Java has this one built in. Oh, oh, I can do match. This is my bad. Yeah. Yep. This is yeah, I can do regular expression. Yeah, and the red match. Pattern and a string. What's the string? String is PB, which is this one. You can even do this in one line. All right. The pattern will be start 1, and then we're gonna have 0, like 1 or more zeros, and then end. I have to check. I'm not sure. It feels wrong to me. Rejects. It feels wrong to me. First of all, we're gonna store these. Position. Start. Match with 1, match with 0, match the previous token. 0. Yeah, that's true. So we just run 1, 0, 0, 0, 0, 0, 1. Yeah. So I guess this one should work. Oh, we don't even need to do check because then it won't match. Yep, that's the one. Like even better than all the one we done previously. Let's check. Oh, I just call NumPy. I think that one shall work. Ah, nope. We do have to import it. This one shall be faster, I think. Oh. Okay, it was loop. Give me 76 milliseconds. And this is also sorry, 76, 65%. I'm surprised this one is actually the slowest. Require 200 milliseconds. I mean, you're using another library. Oh, that's at the end. That's one of the recommended solution. Mathematical. But complexity unknown. Integer limitation. Yeah, that's the one we use as well. Wait, what is this? Possible value of n. Control R. The only divisor to do is divide this by n. Ooh. Oh. Oh, wow. Oh, wow. Oh, wow. This is a very well written answer. Yeah. Power of 3. Yeah, it can be applied to any number. Yeah. A value, we just. Wow. That's amazing. Yeah, this is amazing. No, this can still have the same problem. Yeah, you have to add an epsilon. Okay, this is a very well written answer. Very well written answer. Yeah, can only be prime because it's 3 is a prime number. So if the input number is, wow, this is, yeah, hash works. I use hash. Wow, okay, I'm going to implement 2 more methods. Didn't realize this is actually very deep into this. So use regex for the check, right? And solution 4. Solution 4 will be use log, but with addition of epsilon. Epsilon. Yeah. So need math. And we have to comment out the solution because I don't have NumPy installed. So this is going to be math.log n divided math.log 3, and this one has to plus, say 0, 0, so say to the minus 5, right? And we take an int, and we say 3 power this equals n. Right, I think this one, math domain error. Oh, 0. Well, n larger than 0, and yeah. This one shall be able to handle, right, we put it here, 243, it shall be true. Yep, epsilon. Epsilon is a good addition to avoid what? To avoid rounding error with floating number. E.g., log 243 divided by log 3 equals 4.9999999 by adding an epsilon, we force the value to its correct form. Yep, so that's 4, and a very genius solution 5. Solution 5, we're going to have a value here, max power 3 equals 3 to the 19th power, right? And then, since 3 is prime, and the max power of 3 allowed is 3 to the 19th. Any number, if n is a power of 3, then 3 to the 19 must be divided by n. Yeah. So basically we return is this, and not self.max divided by n. Alright, this is solution 5. Yeah, ooh, this is so good. This is a very brilliant solution, taking advantage of 3 being prime. This is from the official. This is from the official solution. Very well written. Very, very well written. I applaud the efforts in this. See, when a question is simple and you have tons and tons of ways that you can solve it. Amazing. Simply, truly amazing. Yep. Okay, and above that, that's 2018. Yep, true. And then this has to be 1. Very, very good. One line cheating. Nah, that's not cheating. Yeah, that's not cheating. That's being smart, right? That is being smart. What's the question? That's on the. Well, this can just do binary. Power of n, arbitrary integer. Well, any n can be factorized into primes, so we can just do the same trick. Or you actually cannot do the same trick. Any power of 3, right? So what do you think about a power of 6? That's the multiplication of 2 and 3. So it has to be, yeah, we just find, no, oh yeah, we multiply them together. The maximum power of 2 that's allowed, maximum power of 6 that's allowed, and then we do a division. Actually, that's not correct. It should be the maximum power of 2 that's allowed, and then times maximum power of 3 that's allowed. And that actually doesn't scale. All right, I'm gonna read this later. Yeah. Binary search. Yeah. Wait. This could be simplified, right? Yeah. I just need to add epsilon for this. Loop, base conversion, mathematics plus epsilon. Oh, this is a direct copy of that. Cursive. All right. Did he write the answer? No, he did not. It's not a power of 3. Did not divide. Well, the 32-bit unsigned. Yeah, it's the same question. All right, that will be it. That will be it. We spent quite some time on this one because it's a fun question, right? It's a fun question. There are so many different ways to solve it. I'm actually going to change this. This just looks too ugly to me. This looks way too ugly. While not, right, then this it can be divided. We'll keep dividing until we cannot divide, and then when we return what? Return n will come to 1. So return n equals 1. Yep, I think that's it. Solution 1. Oh, hold on. We had a forever loop. How? $27, 0, we do it, right? And then 9 coming up, do it. It's 3 coming up, yeah, do it. It's 1 coming up. One coming up, it should give us 1, which will come out. Wait, what the heck? Okay, this is a 0? Oh, that's 0. Huh. 0, 0, 0. While and not and this, right? That should handle the 0 case. Yeah, after this one's easier. All right, yeah, that's it. That's it for today. It's a quite interesting question, but I mean, this is an even better question, right? To make it into power of n. I'm gonna upload this at the power of n. Got to think about it. The power of n probably is not that simple. All right, that's it. I'll see you guys tomorrow. Adios.